Hello, I'm Christine Curran, and we are Windbelt 422, and we are here today to talk about wind energy technology for the Makran Coast, Pakistan. Let me introduce you to my team. We have Kelly Thompson, who is our president, Jason Schumacher, our chief of technology, Todd Kruger, chief of finance, and John Tassone, chief of operations. Our mission has always been to provide wind energy technology to Pakistan that is reliable, efficient, and affordable. This is due to the frequent power outages, so in order to supplement this need, we want our product to be reliable. Our ultimate goal is to keep energy efficient, and by doing this, we can provide clean energy to Pakistan. Finally, in order for our product to be accessible to the rural Pakistani, we need it to be affordable. Using these three tenets, we have derived our business plan. Our main keys to success are that all people interested in our technology will be granted access for its use. And by access, we mean making it affordable to the rural Pakistani. There's many practical applications such as batteries, clocks, radios, and cell phone chargers that the average Pakistani can use. In the future, we hope to continue this technology to larger uses such as refrigeration. Now let's introduce our customer. Our customer is the rural Pakistani. We chose to focus our technology to the Makran Coast, Pakistan, because this area is in great need of energy. It's historically dependent on fishing as a primary source of income, but with commercialization of fishing and rapid increase in infrastructure, there have been many problems such as political turmoil, pollution, and a lack of energy. Just to get you an idea of the influx of technology to this area, Pakistan has 2 million new cell phone users per month. So in order to meet this need, we propose to use the WB1 Windbelt technology.
Our product is the WB1 Windbelt, and what it is a way to convert wind power to electricity. Now, it's more efficient than microturbines by about 10 to 30 times on average. What it does is it uses belt motion in the wind to move a magnet in and out of electromagnetic coils, which induces a current in these electromagnetic coils to create electricity. The materials used for our product are pretty standard, ranging from copper wire and wood to a belt material made out of mylar-coated tape and magnets. This is a diagram of our prototype. Some of the applications of our product include charging multiple cell phones, powering LED lights, charging batteries, or powering transmission devices of Wi-Fi signal. It's also important to note that you can use multiple Windbelts in series to produce a greater power output.
Windbelt 422's timeline for the next couple of years is as follows. In 2009, there will be an injection of $100,000 fixed, as well as $10,000 in working capital. In 2010, we expect another injection of $10,000 for startup costs, initial expansion, and marketing in the form of street demonstrations in Karachi to generate sales. In 2011, we plan on an expansion to fishermen and more remote businesses, as well as rural areas of the Makran coast. By 2019, we expect expansion into other areas of Pakistan. Our team's finances are as follows. Our startup and one-year operation, we expect a budget of $120,000. $100,000 fixed capital, 50% of which will be from loans, and 50% of which will be from our personal funds. We expect another $10,000 working capital, which 100% will be from our loan that we'll be taking out, and another $10,000 in startup costs, which will be exclusively from our personal funds. We expect to be taking out a 5-year loan of $60,000 at a rate of 10%. With our business plan, we expect a payback period of approximately 2.5 years. Over the 10-year period, we expect to be earning a 40% rate of return on our investment of $60,000. Now, this assumes that there is no salvage of fixed capital, and we also include the loan payment in our 5-year plan. In terms of the net present value of our company over the 10 years that we have planned out, we are approximately worth $1.2 million.
We will initially market the WB1 to the Makran coast of Pakistan, and we will do this by performing street demonstrations to the local people to show how it can be useful in their everyday lives. Over time, we plan to implement or market this to the government for larger implementation as a way to supplement their energy grid. Our proposal is to take out a $60,000 loan to supplement our own cumulative investment of $60,000 already being invested into the implementation of WB1. Half of the fixed capital cost as well as the working capital will be funded by the loan, while the other half of the capital cost and the startup costs will be funded by our own savings. Jason Schumacher, who is WB1 CTO, will allow his house, estimated at $120,000 market value, to function as collateral for this loan. The money will be used to build and operate a small assembly factory for our production and will include materials, flight for personnel, as well as building costs. Thank you for your time, and if you have any questions, you can contact us at our email address, windbelt422@umich.edu.